Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows.
So for today, we're going to be focusing on an incident that occurred in our United Arab Emirates North region. We had a zonal cooling issue that interrupted services on the 30th and 31st of July, 2024. So for our coverage of this incident today, I'd like to introduce a few of our engineering leaders who will be talking us through it. First up, we have Owen Doherty, our Vice President of the EMEA Regional Leader of our Cloud Operations and Innovation team. Thanks for joining us, Owen. We also have Frank Quadras, our Regional Data Center Director for Dubai, also from our Cloud Operations and Innovation team, here to represent our on-site data center team. And finally, we have Siri Velaltho-Pillai, our Principal TPM Manager from the Azure Compute side, who's going to be talking us through some of the long-tail recovery for bringing our hosts back online. Thank you all for joining us today. Owen, we'll start with you. Before we get into the specifics of the incident and the cooling itself, could you just help us to understand a bit of the blast radius here? The post-incident review talked about the region, some availability zones, some data centers, and even a data hall. Could you just help us to understand these characters in the play before we get into the incident itself?
Absolutely, David. First and foremost, before I do that, just on behalf of Microsoft, I do want to apologize to all of our customers for the impact that we've had. We understand the criticality of cloud services in today's modern world, so we do sincerely apologize for the impact that we've had. Back to your specific question, in the context of UAE North, essentially the region is made up of 3 availability zones. And typically availability zones are made up of multiple data centers working together to create that zone. And each zone is geographically independent from one another to protect from a blast radius or natural disaster incident. In this context, effectively, this outage impacted a small subset of one of those data centers. So a single data hall in AZ2 was impacted by a cooling outage. And, again, the reality is any outage of this scale has a potential impact to customers, although I suspect customers who were zonally aware in terms of their architecture would probably be less impacted. But that's not to say there wasn't impact or degradation for some customers in that context. So hopefully that gives a broad kind of understanding of how things are structured from an availability zone and region perspective in UAE North.
Got it. Thank you for that, Owen. That's helpful to understand there. So I think next question for you, Frank, is when it gets to the start of this incident, our initial trigger event, we talked about 12:12 UTC, some hardware began shutting down. Now, obviously, that was in response, as Owen was talking about, to some cooling issues. It sounds like as that initially happened and as that trigger happened at 12:12, our on-site teams were already aware and already investigating some of the problems. Frank, can you talk us through what that looked like?
Yeah, sure, David. So on that day of that incident at about 11:30 UTC, which is 3:30 local time, our monitoring systems picked up a steep rise in the temperature inside a specific data hall. And at the same time, our facility management team also started getting alerts regarding the chiller plants as well. And based on that, a physical check was done, and it was found that the chiller coils, the cooling coils of the chillers, were found to be clogged. And that eventually led to a degradation in the cooling performance, which ended up building the high condensation pressures in the compressors, causing the primary chillers to fail. Right? Now, in these situations, we have a central chiller control panel, which manages the sequence of operations here. And it did send signals for the secondary chiller units to start taking over the workloads. Now, during that time, we had an automation failure, which caused, out of the 2 secondary chillers, 1 chiller lost connection to the central control panel. So although the second chiller did take up the load and did run for some time, it ended up tripping as it couldn't manage the workloads. Now, one of the things is that after that happened, this led to a cascading failure of the chillers, which resulted in complete cooling loss in the data hall. That's when at 12:12 UTC, we started seeing the first customer impact as the temperature exceeded the threshold limits.
Got it. Thank you, Frank. That's good to understand. We often talk about, we try to avoid the term root cause in our incident analyses here, that this is another example of kind of compounding failures where the right different things had to be broken at the same time to cause impact here. So thank you for explaining both those initial chiller issues and some of the compounding issues and falling over to the secondary there. Owen, I understand that since we published the post-incident review last week, we've been getting some more information about the forensic investigations working with our vendor teams there. Do we know more about why the chillers weren't behaving as expected, or is there anything else that we can share?
Yeah, so in the context of the primary chiller system, what's very clear is the environmental conditions in the locality caused the clogging of the cooling coils, essentially. That's not the end of the world in many respects. If you think about the redundancy of the systems, the secondary chiller system should be well able to take the load. The issue that occurred here, as Frank has kind of outlined, is that one of those chillers, if we call them chiller 3 and 4 as being the backup to chiller 1 and 2, one of those chillers failed to start in the automated cycle. Now, the challenge we've had in trying to figure this out is that in the course of the event, as it progressed, we had a series of chiller restarts to try and get control of the situation. And a lot of the actual telemetry and logs associated with basically the control of the system were lost as a result of those resets. So we've been kind of trying to go deeper within the control logic to try and understand what happened with chiller 3. Essentially, what we understand is while the team were assuming that chiller 3 and 4 had taken the load, they were busy cleaning the coils in chiller 1 and 2 to bring those back into circulation. But by that stage, unfortunately, because chiller 3 hadn't taken that load, it was only chiller 4 that was taking the entire data hall load. And that basically led to overpressurization and compressor. It tripped out. Chiller 1 and 2 were already tripped out. And then you got into this cycle of essentially the temperature in the colo or the data hall could not go anywhere. So our loop temperature started to go completely out of control. And at that stage, we're in a position where we had no choice other than to start shutting down some of that IT load to take pressure off the cooling system so we could bring the cooling system back into normal operation.
Got it. Thank you, Owen. Helpful to understand there kind of what happened, the different chillers and the different kind of failures that happened on each. Okay, so we're advancing the story now, and so then the decision was made to start proactively shutting down some of the other hardware that was running in that data hall to help bring temperatures down. So Frank, maybe a question for you. The PIR talked about both some shutdown of hardware being automatic and some shutdown of hardware being manual, people pulling levers to shut things down. How should customers think about each of those, the kind of automated versus manual shutdown here?
Yeah, so essentially it comes down to the SKU design of the hardware inside the racks. So what we noticed during that incident was that the storage racks had a built-in feature in terms of temperature control, where it triggered an auto shutdown when a specific temperature threshold was reached, and that is essentially again to protect data and also prevent the hardware from damage. On the other side, we also are aware actually is that certain IT equipments like network devices and compute devices have a relatively bit more tolerance limit to high temperatures. So those are the ones which we had to manually shut down when we eventually took a call to shut things down.
Right, understood. Okay, so once we power down the rest of the equipment that was in that impacted data hall, so we shut that down, we're no longer producing that heat, we're letting the room cool down here. Could you talk us through bringing that cooling back under control? And then when we started to restore power, what that kind of phased restoration looks like?
Yeah, so in order to get the cooling system back online and recover from it as well, we had to bring down the water loop temperatures inside the chillers to acceptable limits. So the only option available was to shut the heat loads, and that was by shutting down the IT equipments inside the data hall. So after we shut down IT equipments, it did take several hours to bring the temperatures down for the chillers to recover. But then that eventually helped us to bring the chiller and the cooling back under control. So once we reached to a limit where the temperatures inside the data halls reached to an optimal level, that's the time when we started initiating the phase startup of all the racks, as per the runbook processes. So we started with the network racks to start with, followed by storage and then compute. And after which the logical recovery started to take place.
Got it. Okay, that's helpful. So that's re-energizing things. We'll get to Siri in a moment to have a look at what happened after that power was restored. But just while we're talking about the data center side of things, Owen, I wanted to come back to you. The post-incident review talked about several learnings and repairs. How are we improving around, we've mentioned, preventative maintenance and drill procedures. Could you just summarize the improvements that'll happen from a data center side?
Yeah, clearly, in any outage, you've got learning opportunities, and there's no difference in this case. Typically, these types of outages are a combination of people, process, and equipment. So we've got a bit of work to do to improve how we respond to these incidents. In this specific case, I think the initial issue here around the clogging of the coils has kind of highlighted a challenge for us that's really only materialized in the last couple of weeks for us, because we would typically do checks on these every 2 weeks, but in recent weeks, we've seen a huge increase in construction activity in and around this specific data center, and added to the environmental conditions, dust storms, and so on forth. The system's clogged much quicker than that 2-week check. So we've had to kind of go back to the drawing board and reassess. We're now doing that check on a weekly basis, but also during routine walks during the day, we're taking a look at those chiller coils to ensure that they're not clogging faster than we would expect. Clearly, one other area of concern for us was the level of detail in the emergency operating procedures that would help the technicians to react to this and respond to this incident in a speedy manner. We feel we've certainly opportunities to provide a lot more detail in those procedures so that the technicians don't have to kind of try and figure out some of the solutions themselves. And some of that's in respect of alarm monitoring. We've also kind of realized that in this sort of scenario, there's a deluge of alarms that were coming into control room, and it's kind of hard for a technician to see the wood from the trees in that context. So alarm prioritization, characterization, these are all things that we need to improve upon. So I think there's a number of steps that we're already taken and we're actively working through. And clearly, from an automation point of view, we're still, from a forensic perspective, trying to understand the situation with Chiller 3. So we're still working through that at the moment. And my hope is in the next we'll have concrete evidence as to what the issue specifically with that chiller was.
Got it. Thank you for running us through those learnings and repairs. And like many things, that these investigations are ongoing, especially when we need to get into forensic analysis of hardware and how it performed. These things can take months, not weeks. So I'm glad that your team is still leaving no stone unturned to identify more contributing factors and potentially more improvements here. That's really helpful to understand the data center perspective here. Siri, I wanted to bring you in here. Siri's from our compute team. A lot of the consternation from customers in this incident was after power was re-energized, after the cooling and everything had been sorted in the data center, this long tail recovery for some of the downstream services that in some cases took hours to come back online here. So Siri, after temperatures had stabilized and power was restored, could you talk us through what delayed some of the host servers from coming back online?
Yes. Yeah, so let me walk through what happened. So this on the compute side, we have some of the newer hardware, the newer nodes, the newer compute racks with the new technology called Azure Boost. You could find out more about it on aka.ms/Azure Boost. What is Azure Boost? Azure Boost is offloading virtualization processes to dedicated hardware and software. And you see a picture of that card on the side there. And what does this do? It allows us to significantly improve the workload performance around networking storage while providing enhanced security and maintenance of that node. And so this dedicated Azure Boost hardware has additional cooling capacity, thermal event detection. It's basically an independent system for security reasons, performance, and maintenance reason. And think of it as it's running in parallel to the main CPU that you have. During this event in the UAE, the thermal event detectors on the Azure Boost kicked in. They detected rising temperature, and obviously to protect hardware and to protect the workloads, it did the standard things. It increased the cooling of the fans by turning up the fans on itself. And in some cases, that's all that's needed. In a normal data center, it increases fan spin rate and it increases cooling, and it's fine. It goes back down. In this case, the thermals kept going up and up. And at this point, if it were a single cluster, it would do the rational thing and take down that particular card or that node down. But in this case, since all of the nodes in the cluster went down, it resulted in a lengthy recovery of each of these nodes.
Got it. That's helpful to understand that there's some irony of the Boost system having improved thermal capabilities and then ultimately kind of tripping us up here when it comes to the recovery. So last question for you, Siri. What are the relevant learnings or repair items from the compute side? How are we going to make sure that these hosts behave as intended and come back online more quickly after these kinds of cooling or power situations?
Yeah, and this is definitely a learning opportunity for us. We need to take this information, and we are doing that and doing what other things we could improve short-term, long-term, so we don't repeat this, and also take this learning to all the other data centers around the world. So what's the first thing we're doing? The first thing we're doing short-term is we're turning down the threshold at which Boost shuts down. We had too much margins, and we don't want to preemptively shut down too early. So that's sort of the immediate thing to say, hey, don't shut down too early. The second thing is when you have one node going down, it's fairly okay to recover that. But when you have a large number of nodes going down in a rack or a cluster, it took a long time to recover those nodes. So what we want to do and we're working towards is what we call automated bulk recovery. So it's not just one or two, you do the whole rack and the cluster from thermal protection events. And the design for this that we're working on is that once you do bulk recovery, you're not sort of serializing the recovery time. You could do a whole rack or cluster much quicker. And that's what we're working on, developing the infrastructure to do that.
Cool, great, thank you very much, Siri. So it sounds like there were learnings from the data center perspective, learnings from the compute host side, and I wanted to add to this some learnings from the comms perspective. So I represent the Azure comms team hosting events like this one, and we know that the communications for this event, especially such a long-running event, could definitely have been improved here. So I think on-site from the communications perspective, there was some hesitation from the comms managers involved in going wide without actually having a direct list of which subscription IDs and which customers were impacted by this here. It wasn't like this was an entire zone down. This was about a quarter of one availability zone. And our impact analysis wasn't very good at determining exactly which customers and services were impacted by that. So as some servers started to be impacted and as we were shutting down servers, a lot of these services were automatically sending out comms thanks to our auto communication system. So if you were using services like virtual machines or storage, SQL, app service or app gateway, they had automatic comms going out explaining that there was a problem. And we followed up with that to give more details on the underlying data center or cooling issue. The comms were even more delayed where we were requiring manual comms lists that for scenarios that weren't automatically onboarded to that auto comms scenario. So if you were using Azure Container Registry or Azure Site Recovery, Azure NetApp Files, backup, I think Azure Databricks or MySQL or PostgreSQL, those comms were delayed while we needed to work with the relevant engineering teams to determine exactly which customers were impacted, who was on those impacted hosts in that data hall that had the cooling issue here. So we know those delays with comms definitely hurt customers, and we need to do a better job of that timely communication to get word out to customers quickly. Our current policy is to over-communicate. We didn't live up to that during this event. What we should have done in this scenario is communicated to the entire zone, or even communicated to the entire UAE North region to say that we were aware of something, even if that meant the comm went out to customers who ultimately weren't impacted, who weren't, having any services in that impacted data hall. And we mentioned in the post-incident review a repair item from the comms perspective. We're actually working on a specific communications playbook designed for thermal events like this one, so that we can inform customers proactively. As soon as the decision is made, we're going to be shutting down, the infrastructure in this data hall. That will be our trigger to get communications out to customers as early as possible, ideally before the shutdowns, but these things can happen pretty quickly. And we're working on some tooling investments that'll help support zonal and even scale unit-specific impact analysis so that we can send comms out even more quickly here. So there we go. We've got learnings from the data center side, from the compute side, and even from the comm side here. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.